Okay, well, good morning, everyone. I think we'll go ahead and get started. We're very excited that you're here for our tutorial on portable, scalable, and reproducible scientific computing from cloud to HPC. I've mentioned it a couple of times, but if you're just joining and you haven't already, please go to the conference schedule page, look up our tutorial and click the link. I think Sean has also put the link in the Zoom chat. It'll take you to this form. You can fill that form out to get a training account and training account password. And that account will allow you to run jobs, run HPC jobs on our Stampede supercomputer during the tutorial. So yeah, we recommend that you do that. We're going to be doing everything, all the contents of the tutorial are going to be done here out of GitHub, on GitHub pages. So we'll be following along this. We also have a Slack channel. So if you're interested, you can join our Slack team by going to the link here on tapasproject.org to join the Tapas community. And then we have a Slack channel for this tutorial today. If you'd like, but you're welcome to also use the Zoom chat or any other number of mechanisms. Yeah, and so with that, I think we'll go ahead and get started. So my name is Joe Stubbs. I lead the Cloud and Interactive Computing Group at the Texas Advanced Computing Center. I'm very happy to be joined by my tremendous colleagues here. So we have Anagha Jamthe, Steve Black, and Julia Looney, who are on my team, also at the Texas Advanced Computing Center at the University of Texas at Austin. And then we're also joined by Sean Cleveland, who's a research scientist at the University of Hawaii, and who is a co-PI on the Tapas project. So as I mentioned, all the course materials are here available from GitHub. And yeah, just to kind of get us started, by the end of this tutorial, our goal is for you to have a basic understanding of the following. First, the challenges associated with computational research. So specifically portability, reproducibility, and collaboration, as well as some of the tools we have for addressing these challenges. So we're going to talk a fair amount about the Tapas API platform. I'll be doing an introduction to Tapas momentarily here in these slides. But throughout the tutorial, we're going to talk about how you can incorporate Tapas into your own research computing tasks to help you with some of these challenges. Today, we're also going to be talking about container technology. So we're going to specifically be talking about Docker as well as Singularity and kind of where it makes sense to use which and for what purposes. So we'll get into a little bit of that. And then finally, we'll be talking about interactive computing and specifically Project Jupyter and how you can use Jupyter notebooks for interactive computing. So the bulk of this tutorial is going to be very hands-on, but we thought we would just get started today with a little presentation, giving some of the background material, some of the motivation, and a sort of gentle introduction to Tapas, which is one of the tools that we're going to be using. Okay, so as sort of a backdrop, we look around at the national cyber infrastructure ecosystem, and we see lots of powerful tools, right? Lots of capabilities for research computing. It really is a robust but heterogeneous landscape, right? Comprised of a lot of different systems, specialized to a number of different areas. So that is today high performance computing, high throughput computing, data science and visualization, large scale data management, cloud computing, experimental architectures, right? On and on. All of these areas involve their own sophisticated ideas. So just at TAC alone, where my team is, we have over 12 production systems. This slide depicts those here. So you see pretty much a system covering most, if not all, of the architectures, computing models, and paradigms of the previous slide. So we just see this as a lot for the computational scientists to master on top of their own research domain. If additionally your research involves geographically distributed components, then there are even more challenges, right? So often this is a sort of multi-stage endeavor where the first stage is just getting at the raw data. This involves, getting at data from various sources, including sequencers, telescopes, shake tables, wind tunnels, lasers, you name it. You get some raw data off of the instrument, which could be distributed pretty much anywhere. And then you often need to do some kind of data pre-processing task. And this really could be anything from some very simple quality assurance, QA steps, to some very robust machine learning, right? So that in and of itself is almost its own industry. Next, you typically pass to some kind of model simulation. This is what we typically think of as traditional HPC. But even this has really changed a lot, right? Especially with the introduction of GPUs and CUDA and the various, supporting ecosystem of tools there. Finally, if you actually get something useful, you get some good results, then you're tasked with sharing and disseminating those results to the community, right? And there's a whole host of concerns to address here. There are permissions for the various digital objects that you have, not just the data, but also the applications, the workflows, right? You want to enable folks to see your results, but also potentially reproduce your results. So this is a lot we see. And so the Tapas project really is aimed at trying to help you tackle some of these challenges. So what it is, so Tapas is an NSF-funded web-based computing framework to support computational research. Generally speaking, it is domain agnostic, and it allows or enables investigators to leverage storage and computing resources across various institutions. To be a little bit more technically precise, Tapas is a set of hosted, that just means it runs in the cloud and you don't have to install it, but hosted REST APIs together with an ecosystem of tooling, including software development kits in a variety of different languages and an official command line interface for securely managing data and executing code on a variety of different resources, including high performance computing, high throughput computing, and cloud systems. So we have 3 higher level objectives that we're trying to achieve for users with Tapas. First is a sort of unified programmable access to advanced resources. What we want is for you to have this one common API, the Tapas API, that allows you to interact with a variety of different storage and computing resources, regardless of the underlying technology that is operating there. We want to help you reproduce your analysis. So Tapas tries to record all of the behaviors that you take in the platform, all of the important actions that are taken, including inputs and parameters to jobs that are run, outputs that are produced, and so forth, so that you or your colleagues, your collaborators, can rerun your analyses. Finally, the collaboration aspect. We want to empower you to share your data, but not just data, workflows, applications, really any digital asset you have created in Tapas. And again, this is all running in the cloud. So while it might be a complicated stack of technology, you don't have to manage it. So we really have 2 versions of Tapas, 2 production versions, what we call our legacy production version, which is V2, with the primary capabilities that you see here. And then our V3 version just went to 1.0 production last month. So it's a large set of capabilities. We'll be focusing on a handful of things in this tutorial, and there's a bunch of new stuff in V3. And so we'll be using the V3 platform for today's tutorial. But we just want you to know that it is a large ecosystem. There are a lot of different capabilities, many of which we won't be discussing today. And so if you are interested in learning more, we encourage you to look at our docs or reach out to us. Okay, so how do I use Tapas? Well, Tapas is just an HTTP API. So any client that can talk HTTP, you can use to interact with Tapas. So for one thing, you can just use the curl command line client, right? You can make a curl request like this to list apps that are available in the Tapas API, and that will return a JSON response, which you can then parse. We have, as I mentioned, the official command line interface. This kind of provides, we think, a slightly friendlier syntax to curl, but it's a program that would be used within the shell, within the command line. Then we have our language software development kits, our SDKs. So Python and Java in particular, and JavaScript, those three in particular. These give you sort of higher level language bindings and a nicer syntax to work with Tapas in a particular programming language. So this, for instance, would be how you submitted a job in Python. Using, again, some idioms, some syntax that's familiar to that language. And then finally, web applications, such as science gateways. We have a lot of science gateways that are built on top of Tapas. And so it's possible, if you're using some of those science gateways, that you're already working with Tapas. So this slide just kind of covers a handful of the projects that are using Tapas. Really, we do have everything from large kind of double-digit million science gateway projects funded by the National Science Foundation to individual labs, professors and other researchers working in individual labs, working directly with Tapas. This next couple of screenshots just is to kind of show you that we have a lot of science gateways that are being built on top of, or have been built on top of Tapas. They really do span the spectrum of domains of science and engineering. All right, so I thought we would just conclude here with a little introduction to the primary services. So you'll be doing a lot more with these over the course of the tutorial, and we'll be doing a lot more hands-on in particular with them. But I thought it would be good to just kind of give a quick overview of sort of the four core data management and code execution APIs. So these are our systems, files, apps, and jobs APIs. And to begin, we'll start with systems. So systems are in Tapas the abstraction over compute or storage resources that you're going to use, right? So these are your cloud, your high throughput, your virtual machines, your servers, or your HPC machines. And when you're starting out with Tapas, primarily the first thing you're going to do is you're going to register one or more storage or compute systems. Again, these are the things that you're going to actually manage data and run jobs on. So Tapas doesn't install or run directly on any of these systems. Instead, it connects over the network to them as needed to perform the various tasks that you want it to perform. So once you've registered a storage system, and you typically do that like one time or a small number of times at the beginning, then you can use the files API to actually manage the data on that storage system. So the files API provides endpoints for doing basic listing and metadata management to ingest, so upload as well as download. It also has an asynchronous transfer endpoint, so you can schedule a transfer from two storage systems, from one to another. Next is the apps endpoint. So this is where you register your codes, your scientific codes, your applications that are going to run on the compute systems. And similar to the systems API, you kind of use this a handful of times at the beginning, just to kind of get your applications registered. You may return as new versions of applications come, but you primarily do this kind of a small number of times. And then you work with the jobs endpoint to actually invoke those applications. So jobs is where you instantiate the specific applications on the compute systems. And jobs also allow you to move data, input files to compute systems from other storage systems as part of the life cycle of the job. And again, it's going to be capturing, all of these endpoints are going to be capturing metadata about what you're doing. And in particular, the job service is going to be capturing a lot of metadata about how the job ran, when it moved from different stages, and so forth. So I'd say this is just a crash course. We're going to be overview. We're going to be talking in a lot more detail here in the coming hours, but I just wanted to give that brief introduction. And so with that, I'll say thank you, and I will stop sharing my screen. check the chat here to see if we have, okay, this is questions about that. Very good. I believe we're going to be turning it over to Julia.
Yes. So let me share my screen here. All right. So you all should have access to this web page here with all the course material. And so, yeah, I'm going to be walking you through the first part here, which will be an introduction to Docker, getting set up using Jupyter, and then an introduction to generating Tapas tokens and that sort of thing. So hopefully you've all heard of Docker at least. And so basically what Docker is at the end of the day is containers, a way of containerizing processes. And so what is a container? It's basically an isolated process. And you can see kind of in this diagram here, you know, this right here is kind of represented as the containers. And you know, it's a lightweight, just kind of has the application and some libraries, and then you know, it's on top of the rest of the, you know, the host. And so one of the big questions that usually comes up with containers is, what's the difference between a container and a VM? And this is a very good comparison. So a container is an OS process level isolation, and it can run, so you can run thousands of containers on a single machine, and it leverages the kernel features, and the startup time is around 100 milliseconds. And so like comparing that to a VM, we have OS level isolation with virtualized hardware. It can, and you can run only dozens of VMs on a single machine, and it requires it has more physical hardware requirements, and its startup time is a bit slower. So really, with a container, we have it's kind of we have just what we need to run what we need, instead of having an entire VM. And so for most of the container stuff we'll be doing today will be Docker. It's kind of the main containerization that everyone uses. And so there's multiple aspects to the Docker platform. So there's an image, which is kind of the template that these containers are created after. And then we have the container runtime, which is what creates containers based off these images and runs commands. And then there's a Docker hub. And so this is, it's a little similar to GitHub in that it's kind of a public repository for storing these Docker images. And then there are also some additional tooling that's available. So, there's some APIs, there's Docker Compose, Docker Swarm. You don't really hear much about Docker Swarm anymore, but there's different tools that are also available for Docker. So to kind of get started here, we're first going to see if your machine has Docker ready to go. Hopefully it does, and if not, we will be here to help you. So we want to make sure that we have Docker installed properly. So to do that, make sure you can access the Docker daemon. And so what you can just do is go open up your terminal and just type Docker version, and then it should come up and give you some information on the version of your installed Docker. So I'll give everyone a moment to test that. And if you have any kind of issues or questions, definitely let us know.
So, Julia, we were going to mention folks have access to Jetstream VMs if they don't have Docker installed on their system, and so everybody should have gone to the the link hopefully and been able to get some training account credentials. So you can actually, let me see if we get the URL here that we just had. So each training account, I'm going to paste this in the chat. There's a Google Doc link here that just has, maybe Julie, you want to go to it if you click on it and just show people. There's the training account that you are registered with. There's an IP address that you can go to and log in to the virtual machine that we have running on Jetstream. Oh, they don't have access to the doc. Okay. So if someone wants to, I guess, get like a public, make that whoever created that give us a public one, and we'll share that out.
Yeah, let me get a link.
But yeah, so we have a virtual machine for everybody with training credentials for this tutorial, and it's already got Docker installed on there and Singularity installed. Yeah, if your machine's not set up, you can actually run all of these steps in that virtual machine, and you'll actually be running some of the Tapas jobs on the virtual machine as part of this workshop.
Yeah, it's completely up to you. You're welcome to run them on your own laptop if you prefer. The virtual machines will be torn down after gateways, but yeah, if you have any issues with Docker or just prefer to be running in a VM, I put a link in the Zoom chat just now. Hopefully everyone can access that. Let me know if that works for you.
Yeah, and you'll also need this IP address to be able to register one of the compute systems that's going to be the VM. So.
Yeah, so this is what it looks like in case anyone was wondering. So it looks like we have a fair number of people who've already filled it in. So that's great. Okay, so yeah, I'll give everyone a moment to either use the VM or do it on their own computer. Yeah, and thank you, Sean, for jumping in there with that.
Sure. Yeah, and if anyone has any problems, feel free to reach out in the chat or the Slack.
Okay, so how many people have been successful in running this basic Docker command so far? Okay, great. I see some thumbs up from the participants. Okay. Then yeah, let's go ahead and move on here. So I guess, can you all still see the screen here? Okay, cool. So yeah, so now that made sure Docker is running, we can move on here. So now we're gonna create a directory just to contain some of our work here. So go ahead and did you want to say something, Sean?
Oh, we're just getting a lot of feedback.
Oh, yeah, I hear feedback from you too.
Please remember that you all are signed into both GatherTown and Zoom to have both of them muted, because if you have them both on, they can feedback on one another.
I don't have it open. Am I echoing?
Not for me. You sound good to me.
Sean was echoing for me. Joe does not echo for me.
Yeah, and you're not echoing for me, Julia. I did hear
Okay.
Sean echoing, but that was the only time I heard.
Okay, I'm going to keep going. Someone type in the chat or something to tell me to stop if it gets really bad or something. I don't want to have you all go through that. So, assuming I sound okay, yeah, go ahead and make a new directory. Just, make dir docker and then cd into that directory, because we're going to be like making some files and stuff. So before, to run a Docker container, we need an image. And so that's kind of the template that it can be, that shows the runtime, like, okay, this is how we want our container to be. And so one of the great things about, okay, sorry. It looks like, yeah, it looks like being in GatherTown is what's causing feedback. So if you're getting feedback, exit out of GatherTown. Okay, so yeah, so before I mentioned Docker Hub, and so one of the great things about Docker Hub is you can basically just pull already created images from there and go ahead and run them. And so there was also, a lot of things have official images too, like Python has an official image, so you can even base your own image off of the existing Python image and add on to it. So you don't have to worry about installing Python and all that kind of stuff, but you can just use what they already have. And so for this tutorial, sorry. Yeah, so for example, this is an example. So when you create a Docker image, you have the repository and then the tag or the name and then the tag. So in this case, if you see this Tapas /Jupiter, this is our repository name, and then this is the name of the image. And then if there was a tag, you'd see like a colon and then maybe like 1.0 or something like that. Okay, so now we're, that being said, you can practice pulling and running images. So we can, again, check our, go ahead and check your Docker installation to make sure it's run. You can do, run a hello world just to make sure that running something in Docker is working. So running, doing Docker version might not be enough to know if it's going to be able to run something. So go ahead and see if you can run the hello world. And then we're going to practice by pulling the image that I just mentioned. So all you'd need to do is type docker pull Tapas /Jupiter. And then you might have to wait for it to go ahead and pull that. And then you can run it by using this command here. So docker run, and this --rm means that it will remove the container once it's gone, or once it gets stopped. And then we're going to have to allocate this port for, this is the port that Jupyter likes. So we're going to be running a Jupyter server. This is the port that Jupyter uses. And then you specify the the name of the image that you're using. So once this is done, then you should see it should come up and say that you know, it's running. That's when you know you're successful. So I'll give everyone some time to do this. The rest of this is optional for this. We're not going to go through it for this tutorial, so just to save time, but you can go through it later or if you get ahead. But yeah, I'll give everyone some time to go through this and see if there's any issues that we need to help with. Okay, so we have a question that anyone on my team is welcome to jump in because I'm not sure if I can answer it as fully as some of you. Could you briefly describe the differences between third-party software and Tapas container, why they are needed, and security aspects baked into the Tapas base image?
Sure. So this is a good question. So the third-party software in the Tapas container that you're pulling is primarily first and foremost Python. So I believe it's Python 3.8. But we also have the Jupyter Notebook server running in there. So this is Project Jupyter, as well as the Tapas Python SDK. So it's primarily those three pieces together with the the software dependencies of them. So right, it's like Jupyter, for instance, has a number of different Python packages like Tornado and other third-party packages that it downloads as part of its own install. If you're interested, you can look at the Docker file. I believe that's not something we're going to go into in this tutorial, but a Docker file in brief is just a recipe for how you create a Docker image, and it shows you all the commands that were executed in order to build the image. So the recipe, the Docker file for that image is actually publicly available from the Python SDK, the Tapas Python SDK GitHub repository. So I can pull up a link to that if anyone's interested in looking at the details. Hopefully that answers the question.
And we're also getting a few questions about the Jupyter Hub. And so we're actually gonna, right after this, we're gonna go into like how to access the Jupyter and server and all that kind of stuff. So this is just to make sure that you can run a Docker container, basically. So once it runs, it doesn't give any errors or anything, then, you know, just wait and we'll get into that here.
Yep, and I've just posted a link to the Docker file for the image if you're interested.
Okay, let's go ahead and put up a thumbs up if you're ready to move on to the next part. Okay, seeing a few. I'll give everyone like a couple more minutes. Okay. Okay, yeah, let's let's go ahead and move on to the next part. So the next part is continuing on with the Jupyter server. And so after you run this command here, you'll be able to access the Jupyter server. So when you run that, when you do the run statement, it should give you a token. And so you'll need to save that token and then go, you'll have to put it into this URL here. And so this URL will bring you to the Jupyter, your Jupyter server. Now, if you're using a VM, one of the VMs instead of your own computer, you'll need to replace this IP right here with the IP of your VM. So that's the only difference. And then just make sure you put in the token still. And so once you go to this URL with the token, you should be presented with this Jupyter environment right here. And so I'll give everyone a moment to figure that out. So is anyone having trouble accessing the Jupyter server? Okay, I haven't seen any comments, so I'm going to assume that everything's going well. Okay. So Great. Okay. Yeah, getting some good feedback here. Okay. So for this next part, there's multiple ways you're going to need some code that we're providing you, and there's multiple ways you can go about getting it into your Jupyter server. So you can either create a new notebook and then copy and paste the code, or upload the file that from the repo that we provided here. I think uploading it would be the easiest thing to do. But what you can also do is open a terminal, like if you're feeling kind of fancy, or you don't care about the files going away after you shut down your container. You can also just clone the repo from a Jupyter terminal using this here. But alternatively, you'd clone it to like your computer or the VM or something, and then upload the file. But yeah, either one will work. So I'll give everyone a moment to get that going. And so if you want to create a new notebook, you would just click new in the upper right corner, and then choose Python 3, and then you have your notebook. But yeah, I'll give everyone a moment to get through that part. All right, so yeah, we'll go ahead and move forward. If you're having trouble with the cloning, getting the access to the notebook in your Jupyter server, definitely let us know, and we can help you with that. But I'm going to go ahead and move on forward. So next here we have something about generating a Tapas v3 token, and so basically, if you want to use any part of our Tapas v3 APIs, you'll need a token to authenticate yourself. So if you want to read more about kind of the specifics, you could read this. I'm not going to, I won't go into too long of an explanation here, but basically the token is what identifies you in our Tapas system, and is what will give you access to running your stuff on any kind of Tapas commands, really, in running your stuff on Stampede later. So in order to get your token, you will need to run this code here. So you'll see this concept of tenants going around, and we kind of explained that in the beginning part. For this, we're using this tenant here, the tac.tapas.io. That's the tenant we're using. So well, the tac is the tenant specifically, but the whole URL is tac.tapas.io. And so if you'll notice here, we're putting the tenant for the base URL, which ends up being tac.tapas.io. And for the username, you would just put your tac username, tac password, and then the host, I believe, is, wait, someone correct me before I say the wrong thing. Oh, the host is your VM. Okay, that's what I thought. The host is your VM or IP. Oh, I'm going to answer this question real quick. So someone says, I'm running the Tapas Jupyter container on my machine. Can I skip the box account? Yes. Yes, you can. I think. Yes. No, sorry. No.
So you need the box account to get the credentials to be able to access the VM and also access Stampede for the tutorial.
Right. Yes. Sorry. Sorry for the confusion. Okay. Yeah. So the example for all this is in the example notebook, and you can run it there. This is just kind of a added explanation. So yeah, I'm going to pause here also because it looks like we've got some new people who came in, and let us know if you need help with anything.
Right. So if you're just real quick, if you're running running from the notebook, you'll enter your training account, like train 327, your username, and then the password. You'll need the box account to be able to look up that password. And then on that Google Doc that was shared, you can find the IP address associated with your training account. So that host name will actually be an IP address in this case.
Yes, thank you for clarifying.
Yeah, that host address is going to be used later in the tutorial as one of the execution systems, one of the compute systems that you're going to be using. So you're going to be running compute on the virtual machine. So that's why you need to specify that host VM IP address.
Right. Yeah. Actually, the host is not needed to get the initial token for the client, but right, it's just for convenience, just have you enter everything that you need to enter in this first section. So one thing I think maybe has already been mentioned, from this point on, you shouldn't need to copy any or paste any of the code. As long as you have that notebook that's provided open, you can just run it directly from the cells.
So I'm just gonna share what the notebook looks like real quick, just so folks have an idea if of what it might look like. So this here is the image classify notebook that you should have been able to clone down if you ran it. And so I ran that first cell for doing the inputting my training account, my password, and my host. And so it should look like this once you run it. And then once you run the part where you actually create a Tapas client to be able to get a token, and then it prints out the token, it should look something like this. So hopefully everybody is at this stage. So, okay, I will stop sharing and
Okay, I'm going to go ahead and move on here, assuming everyone was able to run this. Okay. So next, we're going to go over a brief introduction to Singularity. And so Singularity is just another containerization tool similar to Docker. And they are similar, but they do have distinct differences. And those distinct differences are what's important here. So we're a little behind on time. So I'm going to just, this isn't extremely important for the tutorial, so I'm just going to kind of like skim through this real quick. So basically, Singularity is the Docker that we the Docker that we use for HPC. And so the biggest distinction is that with Docker, the user has escalated privileges in the container, whereas with Singularity, the same user inside and outside the container is the same. And so you don't have those root privileges with Singularity. And that's kind of the key difference between, that's why we use it for HPC. So there's, most of this is just additional reading that we're not going to cover in this tutorial. This is just, you know, what you can kind of read when you have the chance. But basically, we use Singularity for HPC because Singularity doesn't give the user root access. That's kind of the biggest distinction. Yes, and so now we will move on to the more fun interaction stuff with Tapas systems. So I'm going to turn it over to one of my colleagues here.
Hello, everyone. This is Steve Black. I'm going to welcome. So I'm going to go ahead and cover some of the basic Tapas services you'll use initially to set up various things, and get ready to run a job somewhere, to run your application. So I'm going to fairly quickly just kind of review some material before we jump back to the notebook, which hopefully everyone has gotten set up and running. So Tapas systems, I think it's already been covered fairly well, that a Tapas system represents a some kind of compute or resource or storage resource that you want to use. So it might be an HPC cluster or or it could even be an S3 system, as a storage system. So that's one of the first things you're probably going to want to do is create or register your system or your systems, and or at least see which ones you have available, because it's possible that these have already been set up for you, and because you can, once you create a register system, you can share it with people. It's fairly reusable. So um, so basically what can a system be used for? It's essentially could be used to run a job, which involves staging files, inputs to the system, and executing a job on the system, archiving files and data on your remote system or even that same execution system. And then also independent of jobs, it can be used systems can be used for storing and retrieving files or data, for example, like from an object store like S3. So basically a system is of a specific type, such as Linux or S3, and there are other types under development, such as iRODS and Globus for storage. And it's going to be owned by a specific user, which in this case will be your training account when you create it. Then also another important concept with a system is, although you'll own the system, there's actually also defined in the system is how will Tapas access that system, what user will Tapas go in as on that system. And that can be a static string, like a service account, including your own owner name, in which case it's probably only that very useful for you, or it can be a dynamic user, which we call the API user ID, which is the person actually making the request. So that can make systems quite reusable. So there are pros and cons to each way. For example, if you have a static one, then you can just set up credentials one time and everyone goes in as that user. But that can also be a little bit dangerous. For example, you don't want to set up the effective ID as root, let everyone go in as root. That would be very bad, obviously, hopefully. But if you use API user ID, then there are some other steps to set up things so that those users can access that system. Since they'll be going in, as themselves, they'll need various Linux permissions or whatever their user ID. They'll need permissions on that system, the lower level OS type permissions. So at a high level, what's in a system definition, which we'll be defining one shortly in a notebook, but there's the name or identifier, which is just a short descriptive name, and it does need to be unique within the tenant. And then there's description, which can be just whatever you want, a fuller description. There's also the type, which right now we have Linux, which can be used as storage or execution, and S3, which would just be for storage. The owner, which by default is whoever's making the request, and then the host, which is host name, typically a fully qualified host name or IP address, and here we'll be using the IP addresses for the training VMs. And then the effective user ID, which we've talked about a little bit. And then if it's a S3 system, you need to provide the bucket name. And then typically for a Linux system, you'll also need to provide the root directory, which is essentially a relative root directory for when people are accessing that system. Where does, sort of from a Tapas point of view, where do all the paths start from? So that could be like a user's home directory or certain project directory, something like that. And then there's a flag indicating if the system will be used for execution or not. And then, so let's see, the other things, there are quite a few other attributes associated with running a job, such as the job working directory and the runtime supported. There's Singularity and or Docker are the two we have right now. And so as I mentioned, the systems can be used for storage only, which would mean can exec equals false, or both execution and storage, which is that can exec equals true. So if you want more information, including a lot more information about the various attributes for a system, there's a link here in this documentation. Take you to the read the docs page. So I think I won't try to run this right now, but this just kind of goes over what we'll be doing in the notebook of how to create a system once you have your your access token, your client set up, you can create the system definition, and it looks like this. So it's most of these we've talked about, and this one is set up for. So this is a Linux system on the VM host, which has Slurm running on it. So this will be a batch. So you run jobs as batch, and then has the Slurm as the batch scheduler. And there's this batch scheduler profile, which basically tells Tapas certain things like how to. Sometimes this is needed to tell Tapas how to do things like which modules to load, for example, or sometimes Slurm, like on the tax systems, there's certain options in Slurm you're not allowed to use, like requesting a certain memory. So Tapas needs to know about that. And then also in a system, for this type of system, you'll need to define your logical queues or your queues or partitions that are supported on that HPC cluster, or in this case, it's a VM running Slurm. So here we just have a fairly simple one, which is the single queue. And then you also set up the default queue that will get used if the job requester doesn't specify a particular queue to be used. So that's one thing I did want to mention is, so we have three services that work together when you're running an application. There's the system, the application, which we'll get to in a moment, and then the job service. And actually all three can set certain attributes. In some cases, there are a few that can be set by all three, and many can be set in both the job request and in the application. And typically, whatever's in the job request will have priority, and then if it's not defined there, it will be picked up from the app definition. And then I think there are one or two that also can be set in the system definition. So you can kind of set things up to be relatively simple. So most everything is in the system definition or the app definition, and the job request can be fairly straightforward. Or you can let the job specify many things, which can make the systems and apps much more reusable, which we'll cover a little bit. So, but this is kind of what a notebook looks like. You see here we've got this user ID that can be replaced with your training user ID, but that should happen in the notebook programmatically when you run the cells. So here's just how you create a system. Once you have your client, and you define that system definition as a Python object, a JSON. It's fairly simple create system call. And so one thing you can do in a system definition is define the credentials. But we typically don't recommend that. I think that wouldn't be considered best practice, because if you've done a good job at defining your system, it's likely to be copied by other people or even yourself. So you typically wouldn't want to be copying JSON definition with the private keys in there or passwords. So we recommend that once you define the system, then you need to register the credentials for it, which is a separate API call. So that involves a fairly simple call. In this case, we're going to be using passwords. So you would basically essentially tell Tapas for this system and this user, which is going to be your own user ID in this case, store the password. So that's what this call here does for registering the credentials. And those get stored in the security kernel, and actually can't be retrieved by even yourself, typically, since it's highly restricted information. Only the internal jobs and file service are able to retrieve those credentials, but you can update your credentials, and other people can register their credentials for a system if it's a shared system. So, and that's one thing we're not talking a whole lot about today, is the security kernel, but it is a big part of the Tapas ecosystem. So once you have your credential registered, you should be able to do things like use that system to, well, here showing how you can just retrieve details for the systems. Once you have the client, you should be able to look it up and then see the details for it. And you can also, in the notebook, you'll see how you can, once you've registered the credentials, first thing we'll do is list files on that system, which will confirm that we typed in the password right, for example, and that, Tapas can access that host using those credentials and the system definition. So that's generally a pretty important thing to verify. So now that you have a system all set up, next thing is to define an application. If I want to run something on that system, you want to create your application and run that on the system. So applications, I think that's already been talked about a little bit. This is where you kind of define your codes or your container that's going to be run on the system. I'll try and go through this fairly quickly. There's a lot there. So, but basically an application represents everything Tapas needs to know and combined with the system information in order to run an application on the system. So it'll need to know what inputs to stage the system, and then the container image, that sort of thing. And then and so everything needs to launch the application and then monitor the application while it's running. And then after it's done, how to, what to archive and where to archive it. So you can not do any archiving, or you can archive on the execution system itself in a different directory, or archive to an entirely different system. So one thing about applications is they're expected to evolve over time. So there'll be versions. So the concept of version of an application. For example, you create an application and it works well and it's all set, and maybe you have many people using it. You generally don't want to mess with that version while people are using it. So you can create a new version. And so you'll see when you run an application, you create a job and run an application, you specify the version, which version you want to run. So that's what this versioning scheme is, of course, about. So one thing to note is so for systems, the ID must be unique in the tenant, and for applications, the ID and version in the tenant needs to be unique. And typically, the versioning is kind of up to you, but it's recommended to use a semantic versioning, maybe a 3-level semantic versioning scheme. So here are a couple examples, like your app might have 001 and 002 as the first couple of versions. And even once you create a version, you can update, make changes to that version. So we'll talk a little bit about the attributes, the model for an application. So there's some attributes that are not related to version, like the ID and the owner, don't change with version. And you can change the owner. That's sort of a separate process, but a little more involved. But that doesn't impact the version. And then a number of things that can change with version. So the version, of course, and there's a description, and then the runtime, which essentially it says what kind of runtime this application needs. Docker or Singularity. We'll be using Singularity actually in our example. And then the container image, it's the reference to where that container can be found. Singularity image file, it can be Singularity image file in the system, or it can be actually be proceeding with Singularity. It can be a Docker image that gets converted on the fly into a Singularity image. So one thing, if people can let me know if, let me bring up the chat. I don't know if there are any questions. Okay, someone had asked, what is the value for host when creating the credential? So the host is used, Sean mentioned the host is used when creating the system. And then so when registering the credential, you use the system ID. So we'll cover that in the notebook. Yeah, when we create the user credential, it'll actually be the system ID that's referenced. So let's see, where were we? So in the application, one thing you need to define is, which container to use. And so that can depend, how that looks, depends partly on whether you're using Docker or Singularity. And then there's some other attributes we won't go into much. There are some job related ones, like you can restrict the throughput some, of how many jobs on a system can be run using this application. And then one that's kind of interesting to talk about is strict file inputs. So I mean, the app designer, developer has a fair bit of control on, what can be specified when the job is submitted. So, one thing that typically provided in the job request is which files to transfer to stage there before the app's executed. And the strict file inputs is basically saying that the app is going to fully define which file inputs get transferred. And it does get a little involved, and there to read the docs with more description on that. But strict file inputs, that's an attribute that's used to sort of lock down the file inputs somewhat. Because typically the job can actually request that arbitrary, anonymous, or unnamed inputs be transferred to the system prior to execution. There's some use cases for that. But then strict file inputs would say that, arbitrary ones, unnamed ones are not allowed. They have to be one of the names. So we have this concept of the file inputs having a name or an ID associated with them. So, and then like for systems, there are quite a few job-related attributes, which again, unfortunately, we don't have a lot of time to go into in detail. But things like the exec system ID, and then which directory the app's going to run in, and where the input directory is, and things like that. And which all most of these have defaults for the directories that are probably reasonable for many cases, and they're unique to the job. So by default, they're created under. Actually, back in systems, there was an attribute called job working directory, and so by default, these directories are created under a directory called jobs. So like in our example, we'll have a job working directory is simply called workdir. So that gets created on your VM, and then under there, there'll be a directory called jobs, and there there'll be a unique job ID where the job ID, a directory created for the job ID. So each job will get its own directory, and so everything, inputs and outputs, can be under there. And it doesn't have to be that way. You could actually always use the same directory, but typically you don't want things colliding. If you run the job, it's more than one person is running the job, or even the same person running it simultaneously. You can do that if you have a unique directory. So, and so one thing I did want to mention is the app actually does not have to say which system it's running on. And today we will use this, or if we have time, we'll use this. Actually, the plan is to create two. We'll create two systems, one for an HPC cluster, Stampede2, and one for your training VM. And then, so they'll have the two systems, but the app you create can actually be used for either one. So it won't specify which system it runs on, and that will need to happen when you submit the job request. So as I mentioned, there's a link here for more detailed information on applications, and that's a read the docs link. So this is kind of like systems. We'll just kind of show fairly quickly what the definition looks like, and you'll see this in the notebook also. There's ID and version, which are required, and then you can have a more involved system description, more robust description. And we're going to be running Singularity. And this, I won't go into this runtime options. It turns out Singularity has a couple of ways to launch the image. So we're using Singularity run in this case. And then the container image here, this could be a Docker reference or a path to the Singularity image, the CIF file, which is what we'll use. It saves a fair bit of time. Because it takes a while for Singularity to convert it from the Docker image to a local file. And then you can see here where we're passing in some arguments to the application. So then we register our application or create it just like we did there. So let's, so that's pretty quick. I know we have a break coming up soon. That's a pretty quick introduction to systems and applications. And so So let's go to the notebook. So hopefully everyone's at this point in the notebook. And they've been able to get an access token. So this is one I've actually already used before, but so I've actually already created a system. And then so here's the Jupyter cell where we can create the system. So I'm just going to go ahead and run that. And you see actually it reports an error because I've actually already created it. So it, it says the system already exists. And then one thing, if you do need to update your system definition and make changes, you can actually make a small changes here. You can comment out this create system, and then make your change, comment out the create system, and then uncomment this put system and rerun it. So if I can should be able to do that really quick here and rerun it. And then since I haven't changed anything, and of course it's not going to work. Oh, that's because so there's a typo here. I don't know if that's in yours or not, but yep, there's a typo. This was commented out. So it shouldn't affect you, but there was a copy paste error there. Forgot to update the reference. So here's updating the system, the VM system. Here, since I'm updating, I tell it which system ID, and then this just returns the URL. So it's and then I can see which systems I have access to, and this is sort of a summary for each one. It shows you the ID and some basic information, and you can get information on the specific system. So this gives me all the details for that system I'd already created. And then and so this cell here is what you use to register your credentials. So should be idempotent. I can run that, and it says they were updated, and I'd already entered my password and user ID previously. So the big test now is making sure I can list files on that system. And so here's the list files, and you see it returns detailed information about each file entry. So I might pause here very briefly because a lot of times this can be a little problematic to get set up correctly, like especially if you have the PKI keys, the SSH keys, they can be a little tricky to get in there properly. And if that happens, then this part is sort of your first indication that you have a problem accessing the system. So, but I realize I've probably been going fairly fast. So let me check the chat.
Yeah, so there was a great question from Amit that I tried to answer in the chat, but just to repeat for everyone. So his question was, basically, are the Docker containers that users provide audited for security, and are they run normally in user space? So basically the answer in brief is no. The simple answer is no. We basically, Tapas runs containers exactly the way you ask it to. So Steve's just gone over a lot of the parameters and various ways you can control and configure the way the applications are launched. And so if you have root on a machine and you're able to run containers as root, you have images, container images that run as root, and you're able to run those on a machine, Tapas will do that for you. It will even do that for you with insecure images. So really it tries to be unopinionated. But with that said, I do think the idea of, an opt-in audit, similar to the way GitHub or some other services offer security analyses would be something we could look at for a future feature. So great question. Yeah, thanks for asking it. And of course, while we're on the topic, we do highly recommend that you build your Docker images to run as a non-privileged user, and that you run container images or containers from those images using non-privileged users. Oftentimes that's a requirement based on the execution system, but yeah.
Okay, so one thing I'd like to do at this point is maybe have anyone who's having trouble either post something in the chat or maybe raise your hand if you're having any problems getting to this point where you can list files on your VM system.
So we're about 4 minutes from the break, I think. Do we want to, just pause for questions and things, and then do the break, and then continue when we come back?
Yeah, that sounds good. I may do is, I guess maybe what we can try and do is finish up systems at this point, which is really, if all's gone well, this should not be an issue. Hopefully, here's the so the next one is basically do the same thing for your HPC system. So this will be a different system. It's actually fairly similar to the previous one. There's just a few minor changes. The ID, of course, changes. The host is now going to be an actual host name, Stampede2, and the root directory is actually going to be the root directory of the host, and that's because their job working directory in this case is actually evaluated at runtime with this host eval function. It's because each user in Stampede2, it's hard to determine. It's not like a normal system where it's like your home directory would be home / your user ID, or your work directory might be /work / user ID. Here it's actually got a number in it, which is kind of difficult to figure out ahead of time. So you wouldn't want to have to hard code that for every user, or it's not possible to hard code it for everyone who might use this system. So actually we just make the root directory root, and then the job working directory, when jobs run, actually gets evaluated with this host e value, and it's this environment variable work2, which gets set automatically on the Stampede2 system. So that's really the main difference. So you should be able to run the cell and create the system, and then see that it's in your list and fetch details for it. And then finally you'll need to set in, it's the same password, but you'll need to register it with this system also. So because I didn't try the create, Python didn't set the variable, so I should be able to run that now. There we go. And so I updated my credentials, and then I should be able to list files on my Stampede system, which took a moment, but see, I get back this detailed list of files. So technically I have 1 minute for questions, but at least we'll be here for a little longer than that. So thank you. So I can go ahead and I guess I'll go ahead and stop sharing. I don't know if just people can unmute and ask questions if they want to, or just ask in the chat. I see there's one question about is there CD CI for the container images? I believe the answer is not directly. I mean, you can, the apps are versioned and you have control over that, but no, we don't. I think Joe's answering that in the
yeah, you got it, Steve. I mean, we don't do it directly in the app definition today, but most groups who kind of use Tapas extensively, they do end up setting up a CI/CD pipeline for their apps, and those pipelines really do take a number of different shapes. We've seen everything from things like Jenkins server, Travis CI, to doing things right in the GitHub, with GitHub hooks. So at the end of the day, if you can push your container image to Docker Hub, tag it and version it, then you can have that versioned application be available through Tapas. And yeah, it is kind of on you to set that up yourself. It might be interesting someday to have some kind of baked in service for Tapas applications, but today we don't have that. Anyway, another very good question.
So for Trevor's question here, I think the compressed nature of tutorials this year that would normally be kind of like a full day tutorial to walk through all of these concepts just necessitated having some pre set up things to allow people to get the infrastructure in place to actually be able to run the jobs and get some of the basic concepts. I think the idea of the tutorial is kind of the introduction to the concepts, so that people can drill down and look into more of the documentation to understand each attribute and exactly how those things are working. So we do have additional documentation that I don't know if somebody else has it to pull up or put in the chat, but read the docs link. I think it's in the information. So with that, we're at the break. So we're at the lunch break time. So if everybody would be back here at like 1 o'clock Eastern time, we can restart the last half of the tutorial. We'll look at the registering the applications and running the jobs and all of that stuff for the last part, and then answer any additional questions related to Tapas. So yeah, Tapas is a big API and big ecosystem of things, and so we're focusing on some of just the basic things to be able to get running today. So hopefully everyone will get an idea of that by the time we get to the last half. So some of us will stay in the room here and protect all the laptops and equipment, and everybody else, you can just take off and come back at 1. So Joe, you can correct me if I'm wrong. I think it's whatever container registry Singularity supports.
Yeah, so this is another really good question. So I think basically anything that will work in the Docker run statement or the Singularity run statement, depending on which depending on which kind of application you have, will work. So I think Steve, you correct me if I'm wrong here, but I think it will work if the registry is available unauthenticated. So what we don't have to really be precise, and I think maybe what Trevor is getting at here, so it's also a very good question. What we don't have is like an integration with support for credentials. So if you had a Docker registry, ding ding ding. Yeah, so if you had a Docker registry and you had images in there that were protected by credentials, we can't handle those yet, but that is on the list to do this year. Yeah, that's on the list to do this year. We're trying to figure out the best way to do that. But yeah, we will make it so that you can essentially provide Tapas with a credential. In some form or fashion, it's going to look like providing Tapas with a credential to the registry, and associating that the image associated with the app, associating that with the private registry. Yeah, great question.
So to answer your question, they will get cached. So if the system that you're executing the image on is doing a cache, then yeah, they will cache on that system. So that cuts down on. So the first time it runs, it has to pull the image, and then if cache is supported on that execution system, it'll run faster the next time because it'll just use the cache. And also, I think as Steve pointed out, for the virtual machine, there's actually an image file that is on the machine itself that we're using for the VMs, just because it was taking several minutes to be able to pull and convert that image for the Singularity. So in that case, there's no pull. It's just using the image file that's actually in that /temp directory.
Yeah, it's a tricky question. Right, the images are retained. Yes, exactly. You know, from the other end, you do have to be a little careful with all these things. You have to be a little careful. The best, you know, the recommended practice, right, is when the software changes, when the image contents change, to change the actual tag. And is so long as you do that, then we can keep a nice provenance, a provenance trail of all the different versions. But yeah, it's a good point. It's technically a little bit of a challenge. Yeah.
So Joe, there's no check on the Singularity version on the compute system. It's just going to use the Singularity command, so it should be whatever is installed.
Yeah, I believe that's correct today. I think there are plans to, so in the Singularity runtime, I think you can specify version with plans that isn't actually utilized right at the moment. As far as I know, Steve would be best to give the official answer there. But yeah, with the idea that that'll be used in future. Yeah, when you say so the user is responsible for keeping their images current. I believe if you mean on the Docker Hub, I believe then that's true, right? So you know, if someone has an application with a, you know, it's a Docker image, let's say version 1.0 on the Docker Hub, and then they make version 1.1, they would be responsible for pushing version 1.1 to the Docker Hub. And if they could mess us up, they could mess things up by pushing something incorrect to Docker Hub. They could push the wrong image to version 1.0 even after they'd pushed the right image, right? So yeah, it is technically possible today. So I guess said differently, there is a bit of responsibility on the user's part for maintaining those Docker images. Yeah.
I'm going to go ahead and step out so I can eat something really quick before I go to the next presentation. But thank you guys so much. I really enjoyed it, and I'll let the rest of you all keep talking.
Thanks, Shannon.
Thank you, Shannon.
Thank you.
So, Joe, I don't know if you have the answer for this. Integration support outside of TAC. So, Tapas in general is we use it at the University of Hawaii with our HPC system for some of our gateways and some of our researchers' workflows. So we use it, and I don't know if you have an idea of how many separate systems there were in the last year, but
Yeah, that's a good question. I don't have a good number for outside of TAC. You know, it's on the order of thousands of systems that have been registered with Tapas. You know, most of the HPC systems, most of the Exceed systems I know of, we can support. We've supported systems at the CDC as well, Centers for Disease Control and Prevention. And yeah, and we have had a big ongoing collaboration with the University of Hawaii, and we've run workloads there. So yeah, we've actually been working on a project with the Science Gateways Community Institute. If you'd been to the past Gateway, any of the recent past Gateway workshops, you may have seen us speak on this project. So there's an effort within SGCI that we've been participating in to have a common description of these Exceed systems. So this is outside of Tapas. It's an SGCI wide thing, but you know, it's a way of describing all of these systems, not just the Exceed systems really, but all of them in a common way using a JSON schema. And we've been working, actually Steve in particular has been working hard on supporting that description language in Tapas v3, so that, you know, resources defined in this SGCI description language can be automatically ingested into Tapas. We had a preliminary version of the schema, an earlier version of the schema. We had ingestion working, but then we modified the schema a bit to accommodate some other use cases, some input from the community, and that actually requires some changes. So it doesn't currently work at the moment to ingest systems or to ingest SGCI resources and make systems automatically in Tapas, but soon you'll be able to do that, and with that you'll be able to really talk to all of the Exceed systems, because all of the Exceed systems are in the SGCI resource description. Actually, there's an Exceed API now that JP Navarro's team developed as part of this SGCI effort that describes all active Exceed systems using the SGCI resource description language. So it's really cool, and yeah, and once Tapas complete support for that, you'll be able to interact with those automatically. Great question. So the question is there an effort on the service provider side to support this effort? So if you're an Exceed allocated system, then you're already in the catalog. And that's because if you're Exceed allocated, then there's a requirement to report to Exceed. But we have also, as part of this effort, and I say we, it's really the Exceed team, JP's team, we've been developing, well, there is a software that you can download and run on your say non-Exceed allocated system that will automatically inspect and discover aspects, attributes of the system and publish them to Exceed. And so we are going to be advertising that here this fall, actually. So we were just on a call with JP last week or the week before. And that is kind of the next thing up. We've just been kind of finalizing version 1.0 of the spec. And we didn't want to ask people to do anything until we'd until we'd finalize that spec. But yeah, it will, once we've done that, and actually once the team has finished making some changes to the software is actually correct, but they've been working on some things that are going to make it really simple to run on your resource and publish the data. So yeah, we're finishing up that. Once we have a release of that, we're going to start advertising it to the community. So so if you're interested, we're actually looking for early, people who are willing to early adopt, early test the software. And so if you'd be interested in that, by all means, please, get in touch, and we'll we have a public, the SGCI, as part of this, what they call this tech summit. We have a public monthly meeting. Everybody's welcome to attend. If you're interested in adopting the schema for whatever purposes, your own software as a service provider, what have you, you're welcome to attend. And yeah, and so I'd be happy to get the information for that. In fact, I think it's on our website, so I can probably pull that up. And here's the website. And it does mention the Tech Summit meetings, which are the first Monday of every month. Let's put this in there too. So yeah.
Okay, well, welcome back, everyone. I think we'll go ahead and get started. Hopefully everyone's had a good break and had a chance to return here. And also, as I mentioned earlier, we'll pick back up with applications. But also, if anyone, hopefully everyone was able to create that system for Stampede 2 and list files on it. If not, let us know. And you want to continue following along, let us know. We can work with you to get that going. So now that we have our two systems defined, there's one more thing to do before actually running an application, which is to define that application for Tapas. So covered a little bit of that in the content earlier, and it's very similar to the system. The way we'll go ahead and do it here, it's not ideal. Unfortunately, we won't have time to work, let everyone sort of do more details themselves. So we'll just be running these cells that have the definitions already there. So this is the application definition. You can see this one, it's relatively simple. We're running this image classify container on the VM or HPC. So we have the app ID set here, which should be unique for your user, the ID, and then it's a Singularity app run in batch mode, and then the runtime. I think I talked a little bit about the runtime options already. It'll be Singularity, and then we'll use Singularity run as opposed to Singularity start. In this case, we have the hard-coded path for the image that's already on the VM. And see, these drive attributes, none of these are really critical in this case. There's the archiving capability here, and we're just, for simplicity, essentially turning off the archiving of the various launch files. So that's an option. But also in this archive filter, you can specify which files you want included during archiving or excluded. By default, I think they're all included. So there's more detail in this archive filter, which is not shown here, but you can go to read the docs and see more about that. And then so these other parameters, the question, just very small amount of memory. It's a simple job, small job, and just one node and one core per node, and a maximum 10 minutes. So those are things that can be in the app. So we'll go ahead and I've already created this app. So I should get an error the app already exists, which I see. And if you need to update this app, discussed, you can actually rerun this with a put app. Make a change to your definition and then rerun with this put app. And you should see the URL returned here. And then, of course, as before, we can go through the list. You can see this. My user has can see a couple of different apps, has access to this one just created, and then yeah, there are a couple that during testing, I think I created this first one. The one we just were looking at updated was this Gateways 21, which is what yours should look like, and then we can get details for that, and you'll see a lot more information comes back when you get the detailed information for the application. And so the next section is going to use this application to run a job on the VM system. So I'll let Anagha take over for that. She's going to go through submitting jobs and other things.
Thank you, Steve. Hello, everyone. Let me quickly share my screen here. Can you all see my screen with Tapas jobs here? Okay, awesome. So I know you all are really excited to run the Tapas jobs, but let me give you a brief introduction of what a Tapas job service is. So basically, a Tapas job service will allow you to run your applications directly on the host, or you can submit jobs through schedulers such as Learn. So basically, our Tapas v3 service, it's specialized to run any container applications that on the host that support container runtimes. So currently, we are supporting Docker and Singularity containers. And when you submit a job, the job service basically interacts with several other services such as systems, apps, files, and security kernel in order to process the job. So when you submit a job request, it's basically like a post request. It goes through a bunch of steps. The first and foremost important step is request authorization. So if you're trying to run an application, you should be, it should first check whether you're authorized to access that application. Are you authorized to execute that application on an execution system? And in case if you specify to archive your output to an archive system, you should be authorized to access that archive system. So all these things are checked from, like, for example, your tenant ID, owner, and the user values are extracted from the request that you submit, and also the JWT that you use to do this post request. They're extracted and then they're checked for authorization to applications, execution system and archive system. Once that is done, your job request is validated. It makes sure that you have provided all the required parameters for that request. There is nothing improper values are assigned. So that validation happens. And finally, the job is created and it's written into the database. After that, the job is put on the queue from where the worker will pick it up and the execution begins. And the user will get a response back, which we'll see in a moment how it looks like. So basically, every time you submit a job, you'll get a unique identifier for that job. So every time you want to access information about that job, you can use that UUID, which we call the unique identifier, to get information on. And in the job's lifecycle, it goes through a bunch of states. And there are different statuses that are associated with each state. So at every time, your job must be in one of these states. So first, pending. So basically, when the job processing begins, it will always be in a pending state. And then once the files are identified for staging, it will be in the processing inputs. And then when the actual staging, these inputs begin to the execution system, your job will be in staging input stage. If there are any runtime assets that need to be staged on the execution system, your job will end up in staging job state. And finally, your job is then submitted on the execution system, where it ends up on the execution system's queue, from where the job worker will pick it up for running. Once your job runs and you have provided it to archive it on a certain archive system, it will start archiving the output to that system. If there are not enough resources or if the job is waiting on something, it might enter into a block state. You can also go in the pause state if momentarily the job processing is suspended. And if everything goes right, you have your job output archived, it will end up in a finished state, which is ideally the state that we want. And you can also cancel your jobs intentionally so that, for certain reason, if you feel that you haven't provided proper inputs that you want, you can cancel it in the between so that you don't lose resources. So in that state, it will enter a cancel state. And if something goes wrong with your application, it will end up in the failed state. Okay, just checking if we have any questions. For outputs, are they copied or used? So for now, we are providing it like, George answering it. So if we provide an archive system, your job outputs will be copied to a archive system, and you can also specify the path where you want to archive. Okay. This is a very simple example of like the bare minimum of what a job should include. So basically the most important thing is what application you want to run. In this case, it's like my app, it's just a simple app. And the application, which application version you want to run, and what is the name of the job, just to identify it later. So these are the required parameters. Other than that, in today's example, we'll see how you can use the app and run it on different execution systems. So in that case, you can, in your job definition, you can just have a execution system ID mentioned where it will run the app. You can also provide runtime parameters that are required for user applications, which can be specified in the parameter set. A more detailed explanation of like job submission parameters are given here in the link, which you can refer at your own time. But today, what we are planning to do is we are planning to run an image classifier app, both on a VM and a HPC system. So what this app basically does is like, we're going to classify this image that we have here. It's a cute Labrador image that we are going to classify. And so basically our program is going to tell us like, give us the prediction scores, like what it thinks of that image, like how does it match according to its training set. So what is going to happen is like, when we submit a job, the Tapas job is going to run the Singularity run command. And the options that are Singularity options that are given here are going to be the Tapas environment variables, such as which application directory it should use, what are the execution directories, what app version it should use. All of that information will go in the Singularity options. And the image ID that we're going to use here is like, on the VM, we have already preloaded that image. So we're going to refer to the temp image. And on HPC machine, we're going to refer to the Docker image. And the application arguments, so basically like application arguments are what you can provide to your application during the runtime. Like it's like one or more command line arguments that you can provide. And these are appended to your existing app arguments. So in this situation, we have two arguments that we are going to do. One is the image file and another is the URLs. The URL for this particular example job, what we have chosen is this Labrador image. You can be creative, use any image you want, and let us know the interesting scores that you get back. So what we are going to do is like, we are going to submit this image on a VM and as well as submit this application on a VM as well as submit it on the HPC system. So let me go back to the notebook. I'll give you all some time to go back to the notebook so you can follow along. And then we can start running. Okay, so I've already created this application, which will be running on the virtual machine. So one thing I think I forgot to mention was like, how should the job submission request look like? So just quickly, when you submit a job, you can pass it a name, as we just saw, Description can be, you can provide a description if you like. Application ID is a mandatory parameter that you need to submit. And then execution system ID here, if you see, it's the system ID VM. So whatever system ID we created on the virtual machine, we are going to first use that. An application version is what we register. Along with that, we are going to pass these parameters like the app arguments, which we defined here. So quickly going back to the notebook, you must have already created the application when Steve was letting you know. And then the application doesn't have any arguments, so we are going to pass them in the job. So if you go to the jobs part 1, where we run the image classifier app on the virtual machine, feel free to run this block. So as you can see, we have set up the parameter set here, and also we are doing the job request at the same time. Don't expect to see any output here because we have suppressed the output. We have put it in another variable. So once you see that it runs, you can go on the next cell and try to see how the job response looks like. So this is all the information that you get back when you submit a job. So here you can see what archive system directories it has set, what are the execution system directories it has set, what the name of the job that you have given, and the parameters. So parameters basically puts the image file, and along with that, you can also pass some metadata to it. And now you see the job is currently, like when I submitted a job, it ended up in the pending state. Now, if you want to see your job, you can just do a quick listing on the job, get list function, and then you would see that, okay, these were the jobs I've submitted so far. And this is the current job UUID that I got in response. So to extract the job UUID information, I'm getting this job UUID from the response. Now I'm going to check whether my job, what state my job is it currently in. So yeah, that was pretty quick. It ended up as a finished state. That means everything went fine and my job successfully completed. Now what happens is, like, if you want to go back and see what output your job created, all you can do is, like, you can do a get output download, and you can give the job UUID, which you already stored this in a variable, and give the output path. So your output path could also be like a directory, which is, in a zip format, you can get that output. And now we're going to just check whether it has created any output file. So it gave me a bunch of information which TensorFlow recorded, but the information that is useful to us are these two last lines. In the later section, Sean is going to talk about how we are going to analyze these results. But you can see that it has clearly classified that image. It thinks that it is, the score 97%. It thinks it's a Labrador Retriever. Very few on the Golden Retriever, and so on. So if you have tried any other image, feel free to put it in the chat what results you get. And I can pause for a minute or two here. Feel free to give a thumbs up if you have run your job successfully, or also let us know if you're running into any issues. Feel free to put your questions in the chat or maybe give us a thumbs up if you are able to run the job. Awesome. We can wait maybe a couple of more minutes for everybody to catch up, and then I can quickly show you how to run a job on HPC machine.
So, Anagha, since I think we're gonna have a little more time at the end, do you mind if I show the VM and like you can say exactly what happened in the steps? I don't know if you have yours open.
Sure, go ahead.
Okay.
I'll stop sharing. Yeah.
So for the job that you registered, you told Tapas to essentially run the job, and so the first thing it did, you know, was it connected. If you are on your VM, so I'm on my VM here. Hopefully, you can all see my window. In the home directory, I have the file that we use to essentially run the classifier, the CIF, the image, and then there's a work directory here that Tapas made. So you can actually go into the work directory and you can see, I made a jobs directory. And then if we go into the jobs folder here, there is the unique identifier folder for the actual the job that it ran. So it made a new folder that matches the UID of the job. So if you look inside here, oh, sorry, I can navigate the command line. Inside here, here is the image that it staged, and then it made its own shell script that to execute the job, and then there's the outputs folder. So Tapas goes and, you know, handles automating the process of doing all of this stuff on the compute resources that you choose. And so I just wanted to point that out so that it doesn't all seem like magic, but it's like actually going in and like doing all these things. It's just doing it for you.
Thanks, Sean. I think that was pretty helpful for everybody to see what's going on inside. Okay, for our app to work on HPC, we're going to do a minor change. Either you can, you know, keep the app name same and then just do a put app to include the container image as this. Do you want me to put it on the chat? Or you can just create a new app, call it like HPC, and then just create a new app with that container image. So I'm going to do that. So it created a new app for me, HPC train. If I now do a list of all applications, it should show me my app. Okay. Now we are going to head to the jobs part 2, where we actually try to submit a job on HPC machine. So the only difference that you would see here, if you compare the job on VM and on HPC, are these scheduler options. So basically for this session, we have created, like all these training accounts are put into a certain project, so they can quickly get on Stampede and be able to complete the jobs in this time. So they don't have to be waiting in the queue for long. So now what we're going to do is we're just going to, with the same image that we used earlier, I'm going to submit it on the HPC machine. But this time, you would note that the only difference that would happen is The system ID would be the system ID for HPC, the one that we created on the HPC system. In this case, like Stampede 2. So we're gonna submit this. And hopefully it works. So we don't expect to get any response back from this block because we have put it again there. We can get the response here. And as you can see again, it sets a bunch of things and it is currently pending when I submitted. Let's now check the status of the job. It's currently running. That's a good sign. We can keep polling and check the status. Still running. So moving forward, I think I can show you an example. While this is running, I can show you an example how the job output will look like. I don't want to, oh, unfortunately, I don't have one. It should look pretty similar to what we have from the VM, except that it will have a bunch of information when it was trying to download the image net. It's taking some time to run. So on the VM, it ran pretty quickly because we had already preloaded that image. So, but here we are using a different, like we are doing a pull of that image. So that's why it's taking long. Otherwise, on HPC, it should run pretty faster. See the status again. It's finished this time. Okay, glad it finished. So that means everything ran fine on the HPC machine. So we are again going to go to the same output location, but here it's going to be relative to the Stampede directory. So it's taking some time to fetch that output. And as you can see that these are the logs, which for downloading Inception, you don't need to worry about those. But at the end, at the very end, you would see a similar result with the scores that you were expecting. So I now hand it over to Sean for how to analyze these results and show you some interesting stuff about Tapas. Thank you.
Okay, hopefully everybody can see my screen here. Okay, so at this point, we all should be in our notebook, and hopefully, if your job status, my HPC is still running here. You know, we've created our systems, we've created our apps, we've now ran some jobs, and we're going to download some of the output here. Still running. Let's see. I'm going to change where I'm going to download this from here. This is from VM. Let me get. There we go. So I'm just going to download my output off of the VM since it's already done here. So as Anagha stated, the output file here just captured all the logs out of the TensorFlow run. So this is like everything here that sort of happened. So we don't care about all of that. So we just put a little script here in Python to essentially grab the sections with the actual recommendations. So if we essentially take the output file and we pass it into this little script here, it's gonna do some splits and then just pull out the classifier scores. So yeah, so that's sort of the data that we care about relative to classifier. And so let's see, it thinks that this is a Labrador Retriever, which I believe, yes, is the photo that we ended up using. But in some of the things that we might care about besides the job output is, what all happened to get to the job output. So as we currently have our client here, I think that's what we're using. Yeah. So if you're using the Jupyter notebook, you can we can access the Tapas client object that's currently the registered, if you will, Tapas session that we're currently using to register our systems, our apps, and our files. So if you type in client here in a new cell, so if you're not familiar with Jupyter, you can go to this plus button up here and insert a cell somewhere, and you can type in client, add a period, and if you hit tab twice, it does sort of an autocomplete of some of the options that you have. If we want to look at the jobs, we can type in jobs to access the jobs API, but there's a bunch of other methods that are available. So if you hit the tab, you can see those. But if we hit jobs and we do the same thing, we can actually say, let's look at the job history of one of our jobs. So we've been storing the unique ID for, say, the HPC job in this job UID HPC. So I'm just going to copy that or type that down here because I think I need job UUID equals this. So hopefully you can see that. So job history, and we'll take a look at this HPC job. So if I run that, it should go talk to Tapas, and it should fetch out, all of the steps that happen to the particular job that we submitted to the HPC. So we can see that initially when we submitted it, it went into a state that was pending, and then Tapas started processing inputs on our job. Then it started to stage those inputs onto either. So in this instance, we're looking at the HPC one. So this was on Stampede. So it started staging them, and it tells you exactly what time that started happening. And then it started staging the job. So in this case, so stage our file inputs, then stage our job inputs. So this should be our application staging. So our Docker container, or the converting to Singularity. And then here's the job submission here. So this submitted it to the scheduler, and then it went to the queued status where it was queued into the scheduler. And then finally it started running at this time. And you can see the time steps at which each thing sort of happened. So this is sort of handy. And then finally, after it was done running, I think Steve's been talking about the archiving bit. It started archiving the data to the folder. If we had specified a system or something to archive the data, then it would have done a transfer of the data to an archive. And then finally, once that was done, then the whole workflow is done, and so we get the finished status here. So this is just something else that, as we're talking about reproducibility, Tapas is helping track some of the provenance of some of this information about the job. And I think we glossed over it, but if at some point in the future you didn't know what you let's see, it's a good job. Yeah. You wanted to see what exactly you did to get to this state. We can pull back all the information about the job by just fetching it back from Tapas and saying, where did I run this? Which execution system? So we can go back and we can say, oh yeah, I ran it on this execution system, and we could pull that execution system and see all the details about this. What parameters did I set? All the parameters were stored were stored out here. And so we can say, oh, I use the image file and I set it to this image here. So, you could use this to rerun this if you were trying to, replicate your work later, or if you wanted to share something out, you would have everything that you did here. So you have, this is everything that was captured for, running the job. And then these are all the steps that, actually Tapas did on your behalf to run the job. So you're trying to get, give you the full provenance of this for reproducibility. Okay, so with that, we can talk about sharing your results, because that's one of the things that if you're doing some workflows, you get some data, you want to share it out with other folks. Tapas supports the ability to essentially share out your systems and your data with other users in Tapas. So if we take a look at, let's see, I'm going to find another user here. So Jared's one of my software developers. He's nice enough to be here. So I'm going to share out a file with him. Hide my meeting controls. So if you want to pick a training account to share with, you can edit in your notebook a username, one of these training usernames to share something with. So in this case, I'm going to share out my VM system with Jared, and I'm going to give him read access on there so I can share, say, my files here. So if I run that, let's see, what did I do? Oh, wrong parentheses, so single quote, not double quote. So there we go. So now I ran that command, and so now it says that user ID 309, which is my user, gave user 312 read access on this system ID, which is my VM. Then the next thing I'm going to do is I'm going to share out the working directory. So I showed you that real quick in the from the shell there. I showed you the work directory that Tapas had created and put all of its outputs and things into. So now I'm going to share that folder out with Jared as well. So we'll run that. And so Jared should now be able to do this. So Jared, if you're running through this, if you want to go ahead, you can share with me, because my user's train309. And then I could essentially do a systems list here. So if we do client dot systems dot, I think it's get systems, this should list all the systems that I've got. So there's my 309 training account, and look, Jared shared out 312 with me. So that was nice of it. So yeah, so take a moment to go ahead and do that, just so you know what's going on. And then once somebody shared something with you, yeah, I guess we did this. Let's see, we can look at the details on a system that I shared here. Oops. Okay, so yeah, this was the VM one that I shared with Jared. This is just the details, but to get those, it's just get system is the command that we're using here. We don't have to do this on the system. So since the when you share a system with another user in Tapas, if the system is not a dynamic system, if it's a static system, it will use the credentials that we passed it. So if I use say my TAC credentials to create an HPC system, and then I shared it with Jared, when he was going to download, say, a file using my system, Tapas would say, does Jared have permission on the system? He does through Tapas, so then it's going to access the system with my credentials on his behalf, so that it's shared like that. As we've been talking about, I think Joe was having some conversations about some of the system definitions, and so making them once and being able to share them with a bunch of people, and they can use their own credentials. There is the ability to if someone shared out, say TAC, and you had your own TAC credentials. So you could put the TAC system ID in here that somebody shared with you, and then you could put your own user credentials in here, and then be able to access that system. If that makes sense. So anyway, so once someone has shared a system with you, if it's that dynamic API thing, then you essentially add your credentials to that system, and then you could do the download if it wasn't shared with static credentials with you. Did you want to add anything else, Joe? I see you've got a confused look on your face.
No, no, no. I thought you did a great job. We were both kind of. I was, trying to answer in the chat, and you were answering in the, out loud, and that's perfect. And so yeah, I was just reading the last reply. Yeah, that's exactly right. So yeah, I think we've answered all the questions. The really, really good questions. Just to repeat what I said, sharing a system at the Tapas level doesn't actually do anything on the back end, like on the physical system, on the VM or the HPC cluster or what have you. It's just we don't allow anyone to do anything on any system at the Tapas level. Tapas does not allow anyone to do anything on a system that they don't have some kind of permission for. So yeah, good questions.
So one thing that I will show and mention, and I'll put this in the chat here, we're working on sort of, we've talked about having API, language APIs for Python, which is what we're using currently here in the notebook. So this is one of our Python SDKs. Joe mentioned Java and JavaScript. So we have JavaScript and TypeScript SDKs, and we're currently building out, Jared, who I actually mentioned, is actually working on part of this. We're building out a base user interface that's pretty alpha right now, but you can use your training account to log into this with the credentials, and you can actually see in more of a user interface way some of the things that we've done in the tutorial. So the fact that this training account for 309 actually has some systems in Tapas. There's two apps that have been registered with Tapas because I have a VM app, and I made a new one for TAC, and then I ran a couple jobs here. And you can look through here using the APIs, the systems here. So here, this lists my VM account, my VM system, the HPC, the TAC system here for Stampede 2. And then this is the one that Jared shared with me. And so I think, yeah, since this is the dynamic one, I think I have to actually create my thing on this. So maybe I'll do this here. So let's see, gateways 21 through 12. VM underscore. So my training account. So see if that worked. anyway, there's some things with this alpha, but right now, if you click on your system, you should be able to list files for the VM you made and then the HPC system that you made. So these are the files on Stampede for this account. We look at the apps. These are the two apps that I have. The job launcher here, this is in active development, so it won't work for launching these jobs. Unfortunately, that would have been cool. But for the next gateways, maybe in the spring we'll have that ready. The jobs here, you can look at the jobs that you actually ran, and so if I'd given them some really good unique names, that would be more helpful over here. But you can see I had one failed job when I tried to run it on Stampede using a hard-coded location to the container file that wasn't actually there. So that's what failed here. And then this is the second time I ran that. So getting the jobs out, but anyway, yeah, we have a number of gateways that currently use Tapas, and as we roll out more features in the latest version of Tapas, we'll be rolling out more tooling and things like that that'll be available for folks. So yeah, this is currently coming along. So let's see, hop back to here. Is there anything else that we want to cover? So I think that's I think we successfully made it through all of the things today that we wanted to cover for this workshop. I think we went a little faster than normal since we hard-coded everything for everybody in this example notebook. But yeah, we'll take some more questions. I don't know if folks want to weren't able to get through running any of these things or registering any of these things. We'll stay on for any of that. Joe, is there anything you want to?
Okay, sorry for interrupting, Sean, but looks like some people have issues with running the job on HPC because we updated the app. So I think it will be good to run through it quickly again. So everybody is able to run the job since we have time.
Okay, sure. Yeah, so let's see. Let me just go to the app section. So we created the system, the HPC systems. So with the apps, so one of the things, yeah, I mentioned, so if you had a problem running on the HPC system, if the app definition prior, I think had a hard-coded Singularity file in here that worked on the VM, and we didn't think about that for the HPC system. So if you go into the section to create an application, you can create a new app ID. For me, I just added classify 2 in here. You could say, if I want this to run again, I could say classify HPC. So we'll just change the app ID. So we'll have a new one. And then replace the container image. So I think right now there's like a temp/image classify.cif file. You can actually use the Docker this. So I think I can put this in the chat. I think Anagha put it in there earlier, but yeah, use this. So yeah, so replace that with the container image, and now we should be able to register this app by running the cell. And so yeah, I created this new app, and the app ID variable is now assigned to this. So we can actually, if you run the get apps again, you should see a new list with your new HPC. So here's mine, HPC train. So of all of my apps, I now have 3 I just created. If we fetch, we can see all of the details on that HPC train app. But now if we want to run this on the HPC, we can walk down to that section for running this on the HPC. And since our app ID here has the new has my HPC train ID already in it, I can just run this cell because I'm going to use all the same parameters and the same scheduler and the same account here. So running that, looks like it ran. So if we get the job response here, so then there's my job for running this app. And then I can check the status again and see that, oh, it's already running. So yeah, everybody go ahead and go ahead and try and make this change to the app. I'll just walk back to. So yeah, it should look like this. Oh, sorry. I guess I keep hitting individuals. Why does it keep doing that? Sorry, Alex. I keep direct messaging you. For some reason, Zoom keeps focusing in on you.
No worries at all.
Okay.
Yeah, while we're waiting for that, maybe I'll just kind of take a few moments to kind of stop and reflect on what we've done, right? Because it really is. I mean, it might be easy to kind of get stuck in the weeds here or there, but it really is quite amazing, I think, what we've been able to do here, which is to go from an entirely custom code stack, right? If you look at that image classifier, it's the ImageNet classifier. It's based on TensorFlow. It's a fairly, Python, et cetera. It's a fairly complex stack. We are not actually depending on anything on the actual systems we're running, the VM nor the HPC system, and we're kind of seamlessly moving between the two. And we're actually reproducing our results. And this is, this is in part because of Tapas, but it's actually in part because of all the other ingredients, right? The containers in particular make it so that we can build our software, our codes in such a way that they are virtually, independent of the system where they're running. And I think that's, it's just worth pointing out that's quite a fantastic feat that we're able to do, that we're able to move our research code from, a VM to to an arbitrary HPC system. We picked SAMP2, but it really could have been any HPC system. And we can move it to a third one and a fourth one with a similar amount of effort. So while there's a lot going on, there are a lot of technologies here, a lot of things that we really didn't cover. We didn't really talk very much about how you build these images or how you convert between different types of images, et cetera. It really is a powerful combination of tools that allows us to do stuff that just a few years ago would really kind of be unimaginable. So yeah. Right. So Trevor brings up a good point or a good question. Are the codes in the containers truly optimized for the unique architecture? Is this really HPC? So yeah, that is a great question. The answer is, in short, is no. But it's a complicated story, right? And it depends. It very much depends on the code. I mean, this is an active area of research. We have lots of container images that run optimally on HPC systems. That is one thing to say. And in fact, the HPC group at TAC just published a paper, published and presented a paper in ISC, the International, Supercomputing Conference, this past year over the summer, where they did a lot of benchmarking of container images running on Frontera, our flagship system, and they got near zero overhead or zero overhead in a lot of different examples, a lot of different cases. So containers can get essentially optimal performance. It does take more work though. So yes, portability to some extent today, portability can come at a cost, which is truly optimized, software, but that's not necessarily even true. And in the future, that will be less and less true, right? As we're able to swap, do techniques like swap, MPI libraries, other kinds of things at runtime dynamically, we will be able to get optimized performance and portability. So I guess the long-winded answer is sometimes we can get optimal performance and portability. Oftentimes we do have to sacrifice, but this is an active area of research, and we're getting more, and we're getting closer and closer every day to not having to make as much of a sacrifice for of one for the other.
Joe, I think also had a question about the specifications for the dependencies on memory and node and core.
Basically about dynamic routing at runtime.
Let's see. I'm missing it. I see a lot of some people got things to work. That's very good, but I missed.
Is right about the first comment.
Oh, I see. Does the app author need to specify resources correctly, like memory core count, so the execution happens in an efficient way? Yeah. Oh, okay. Or can Tapas dynamically route execution to be run in a more efficient way? Today it cannot, but that is actually something we're starting to work on this year. So in this demo, in this tutorial, when you were submitting the job, you were specifying the execution system that you wanted Tapas to run the job on. And as part of specifying that system, I want it to run on this VM, or I want it to run on Stampede 2, you need to specify the resources that that you wish for Tapas to request on that system. So in particular with Stampede 2, if you're doing a multiple nodes job, you need to specify how many nodes you want Tapas to request. But what we're doing this year is we are embarking on some kind of R&D work. So this is very much kind of research and development, but to make it so that Tapas can choose from a set of possible different execution systems. So in other words, for you to be able to submit a job, specify the app ID, the application ID, but not actually specify the execution system. Instead say, I would like Tapas to choose the execution system for me based on X, maybe some cost function that is to be optimized. Maybe that's minimum time to solution, right? And then Tapas could take other things into account, like the queue lengths, whether a system is in maintenance and so forth. So that's work that we called out in the Tapas proposal. We're entering year 3 of the Tapas grant, and we charted kind of the last half of the grant for this more experimental work. So yeah, we'll be hopefully able to at least have some papers and maybe do some kind of prototype demo stuff within the in the course of this year. And certainly we hope to have something really cool before the end of the Tapas grant. But it is, just full disclosure, it is total R&D stuff at the moment. So yeah, great question. Some stuff we're really excited about. And actually, along those lines, we're part of this AI Institute that was just funded. It'll start, it starts in November 1st. So Icicle, which is a new NSF AI Institute. We're really excited to be a part of that. And so we'll be collaborating with a bunch of AI researchers on exactly this problem, together with a few other problems the Institute is taking up. But we'll be working hand in hand with some premier machine learning and other AI experts to see if we can actually make this work. We think we can. So so yeah, it won't even be just us. It won't be a toy that we put together. We don't think we think we'll be able to put together something pretty cool.
One plug I will make is there's going to be some Tapas talks this week at Gateways, and so Tapas UI will be one of those talks. So if you're interested to hear more from some of the people who are doing the efforts to do the development on it, you can hear their talks. Joe, I guess there's some other ones you might want to.
Yeah, I mean, I will definitely echo Sean's plug for this Tapas UI project. One thing Sean didn't mention, I don't think, maybe I missed it, but it's super cool about this project. If you notice the URL in his browser, this is all being served out of GitHub. Okay, so tapasproject.github.io. This is leveraging what's called the GitHub Pages feature. So basically, there's a Git repository where Tapas UI, where the code lives, and you can anyway, the application is all static. It is nothing but HTML, CSS, and JavaScript, and so you can serve it straight out of GitHub Pages, this feature of GitHub that allows you to basically turn a repository into an active site. It's what we use today for the course materials as well, so that you could see it kind of rendered nicely. But what's super cool about this is it means you can run a gateway, full featured once Tapas UI development work is done, and it's not done yet. But it'll be full featured science gateway without running any servers, right? What we call a serverless gateway. So there are literally 0 servers to maintain. You would just fork this repository and configure it for your Tapas tenant, and you would be done. So yeah, there's that talk. We are also going to be talking about how we're using Jupyter Hub. So we have a new project called Cinco, Scientific Interactive Computing, that basically combines Jupyter Hub with Kubernetes and runs Jupyter Notebooks as a service on our Kubernetes installation here at TAC. So we'll be giving a talk about that. And there are a handful of other talks that are being given by TAC staff. I don't know if I know all of them off the top of my head. I know we're talking about a geospatial API that we developed, the HasMapper API that we developed as part of some other work. And yeah, so I highly recommend checking any of those talks out.
Okay, one of the other things I'll put a plug in is if you have more questions after this tutorial related to Tapas, you can join the Slack group here for the TAC Cloud and ask questions there or get more help with Tapas. Is anybody else still having issues or problems with running any of the code in the notebooks? Okay. Well, I guess any last things here, like if you're interested in using Tapas some more after this, the training accounts are going to go away, and so is the VM. So you can request an account for attack accounts to use the Tapas currently set up with TAC. And if you want to be able to use Stampede 2, you can request a startup allocation through the Exceed portal to be able to test and run some of the codes there as well. But again, if you have your own systems that you want to register, you can do that using the methods that we have here in the notebook for registering your system. And if you have problems or questions, you can follow up with the team. Question here, this is a good question. Is Tapas v3 open source or only a hosted solution? So it is open source. There is a central hosted solution to make it easy to, to get up and adopt, but you can deploy these codes at your own site. And we actually have a new mechanism in Tapas 3 for having associate sites. So in this instance, essentially, it's the hub and spoke model where there's sort of a central deployment at TAC, and then you could either do your own full deployment. So that's what you used to have to do. But now with an associate site, you can decide to deploy just a subset of services. So if you wanted to be managing your own credential identity provider for accessing Tapas services. So like at University of Hawaii, we have this. So our folks can use their University of Hawaii credentials as their Tapas account. And we host a couple of the API services, and then we leverage the rest of the services hosted at TAC. So essentially you could stand up a subset of services at your site. And then for the services that you don't want to manage, you can leverage the TAC service. So.
Yeah, and I'll mention that one of the repositories in there is what we call Tapas Deployer. I can put that into the chat. But essentially, this is not at 1.0 yet. But this is an automated way to deploy Tapas straight from the source images, and so we're highly encouraging folks. So this is how we deploy Tapas at TAC, and we're highly encouraging folks who are interested in deploying Tapas to do so. Sorry, you're getting a 403 from or 404 from which link? The GitHub link? Deployer is giving you I wonder if that's because I wonder if it's not a public repository. We haven't released Deployer yet, so sorry about that. And maybe it may still be private. But anyway, yeah. So we're still actually actively getting Deployer to 1.0. Tapas v3 is in 1.0, but the Deployer is still. I suspect it to come out in 1.0 in the next maybe say month or so, next few weeks. It's in our development. We're using Deployer for our development instance right now. Let's see, where does the funding for Tapas end? And what is the long-term plan after that? Okay, so that's a really good question and a really complicated one to some extent. So we have funding for the Tapas project directly through an NSF CSSI framework grant. I'm the PI of that grant. Sean's a PI from the University of Hawaii on that grant. That carries us at least for the next 3 years, probably longer, actually, because we will probably do a no-cost extension. We've been spending it down at a slightly slower rate than what we'd anticipated, and that's partly because of the pandemic and some other things. But yeah, so at least for the next 3 years, and that's like three academic years, so 9-1 to 8-30. We will be funded directly on that grant. But Tapas, even before V3, has always been funded by other grants, other projects that we participate in. So I mentioned the Icicle AI Institute. So that is an NSF funded grant that actually starts November 1. And it is a 5-year award that will fund, our effort on that will be to provide Icicle with basically the platform Tapas that it's going to build upon for a lot of its functionality. So that'll be another 5 years from the time that starts that we'll be receiving some funding. And we also receive other grants, funding from other sources of different grants. So so really the long-term plan, I don't know if I can call it a long-term, but at least medium to long, is to keep doing exactly what we're doing, making Tapas free for as many people as we can, and continuing to get funding for big projects that add really major new capabilities, major new functionalities, like the AI Institute, where we're going to be building machine learning capabilities into Tapas, right? To kind of carry it on. We have smaller grants and contracts that we have with individual groups from a variety of different agencies. We're actually funded by DARPA, the National Science Foundation, the National Institutes of Health, NASA. Let's see, who am I missing? So we have a lot of, I mean, it's not like we're rich, but we have a lot of funding. We're a diversified funding. We try to maintain that, so that we can make sure that Tapas can be free, really for everyone. That's the goal. Hopefully that answers the question. What's the business model for the hub and spoke system? Really, it's not a business model per se. Well, okay, maybe I understand what you're asking. Why would someone want to deploy an associate site maybe in a hub and spoke model? The idea would be two reasons. One, you want to basically keep secrets local to your site. So when you're registering a system with Tapas, you are giving Tapas the credential that it's going to use to access your system. And it may be that as an institution, you don't want to do that with Tapas running at TAC, right? Maybe you want to keep those credentials local to your institution. So that's the first reason to run an associate site. The second is data locality. So actually, Sean mentioned his associate site at the University of Hawaii. When you're in the middle of the Pacific Ocean, there is real latency, particularly around data movement. So Sean has Files API and Files workers that can move data between systems at the University of Hawaii much faster than we can do so here in Austin. So those are kind of the two reasons that you would want to deploy any Tapas components. The reason to deploy some but not all, in other words, the reason to do an associate site and not a full-blown Tapas installation is just that it's less to manage and maintain. The full complement of Tapas APIs is something like 14 APIs. There are a number of different databases that we use, message buses, various third-party systems like LDAP and so forth. So, it can be a lot to maintain. And so, yeah, so the ability to run just a few key select components at your site that's going to keep secrets on premise, it's going to keep data latency down, but kind of defer the rest of the management to the primary site running here at TAC is just to kind of lighten the administrative burden on your end.
Yeah. One of the other reasons we also have a site at UH is we heavily use one of the APIs we didn't talk about, the metadata service, for storing and indexing a lot of data for some data repositories and things like that. And so we would, sort of, there's only so much kind of storage that's, fair to take out of, the free pool at TAC. And so we host our own service for that, so we can manage that database and make it, grow it very large. And,
yeah, that's a great point. Yeah, we don't have quotas today on our metadata service, but we know that if a project had really large needs, as one example, from the metadata API, that would need to be a discussion because we do have, and in fact we do have one group. Actually, we have a group that's actually an international collaboration that is storing upwards of 10 billion documents in our metadata API, and for that group we have a custom database and an associated sort of contract that we work with for supporting that. So yeah, that's another very good point, or very good reason to host your own. These are great questions. We thank you all for them. It's really nice to have this interaction, even though we can't be together. Yeah, so I think maybe with that we can conclude. We can be around. We'll hang out here in the Zoom, and if you have more questions, we're happy to answer them. But for those who are finished, and ready to move on, we can say thanks a lot for participating and being part of the tutorial today. And yeah, we look forward to interacting with you virtually in the rest of the conference, and hopefully actually in person at some point in the near future. So yeah, thanks again, everybody.
Yeah, thanks everybody.
So we do have time. So if anyone wants to go ahead and unmute and ask questions or make comments, now's a good time. Not many people.
Yeah, I just mentioned that I got it. There was one in the chat and started to answer in text, but just to clarify, so I realized I hope I didn't mislead folks. I apologize if I did. We didn't cover associate sites, like how to set those up in the tutorial today. And we don't really have, let's say, official documentation on setting up an associate site just yet. For V3. So associate sites in general are a new concept in V3. We've just started rolling out the first couple. The ones at University of Hawaii are the first ones. We're building out this Tapas deployer project, which will eventually, have complete documentation, and we'll be able to deploy these associate sites. But we do not have that yet today. So if you're interested in deploying an associate site, the best thing to do would be to for us to have a conversation. We can make the Tapas deployer project public. We can make that a public repository. I don't see any reason why it's not. So that would be the very first thing that we would do. But that is just the source code. So there isn't any documentation there or any kind of links to help you to kind of help you navigate that process. So the best thing would be to to reach out, and we can set up a chat, to figure out what your use case is and help you get it deployed. But we should have all that stuff this fall, with complete documentation. That's our goal. We'll be hopefully spinning up an associate site for this AI Institute, this Icicle AI Institute that I mentioned, hopefully at Ohio Supercomputing Center or maybe one of the other institutions.
Cool.
So we got to have it.
Thank you, Joe. Yeah, thank you. So one more question if I wanted to try it right now, would I be able to do it on Stampede too? But I need to request an account, you said, right?
Yeah, you need to. So we'll have the training accounts. They'll be around for at least the end of the day today, I think. Although actually, I will tell you that they're in a reservation. So Stampede has a pretty long queue. So the reservation will at least go away pretty soon. Yep. Yeah, so you can use the training account password, I think, to authenticate at least for like the next few hours. Is that right, Anagha, or do they go away faster than that?
I think the account should be there, but reservation will go away faster.
Yeah, I have not requested an account, so I might not, but I think I have an Exceed account. Maybe it's probably need to be reset or something. I don't know. Would I be able to use the Exceed account that I have, XUAP account, to be able to log in and use Tapas?
You need the TAC account right at the moment. In the setup that we have right now that we've gone through in the tutorial, it's okay, honoring the TAC LDAP accounts. If you made an Exceed account, then you can map that to a TAC account in the TAC user portal.
Okay.
And then you can use that one. It'll be like one of these TG blah 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 number things. So if you have one of those, you can use that. Yeah, we've talked about exceed auth for Tapas, but we don't have a tenant right now that can do that at the moment.
Okay. Yeah. So, I mean, if I understand correctly, TAC accounts are not just given out like that unless if I request through a startup allocation. Is that true?
That's a great question. I believe you can get the account quite immediately without getting the startup allocation even. They've kind of made it faster in recent times.
Okay.
So I know, for instance, with the Design Safe project, I don't know if you're familiar with that one. I think you can get an account without any kind of startup allocation. So yeah, if I'm happy to help you get this going though. So yeah, if you want, I would go to the TAC user portal.
Okay.
We can put the link in the chat there if you don't know it, but if you just Google TAC user portal, it'll come up.
Yeah.
If you go there, just request an account, and yeah, if you have any issues, just CC me and I'll see what's going on, how to get it going.
Okay, sounds good. Yeah, thanks a lot. Yeah.
Thank you. Yeah.
Great presentation. Thank you.
Yeah. Oh, I guess maybe he jumped out before the account went there. I think.
All right, everybody. I think we're about at time. Thanks to everyone. And I think I will sign off at this point and go on to the next, but see you again soon.
Yeah, thanks everybody.